we are going to just summarize what we've been doing. So if I have f of x equals a times b to the x minus h power plus k, in order to have a reflection over the x-axis, a is negative. A shrink, and I'm going to go ahead and put absolute value because it doesn't matter if a is negative or positive. If you ignore the negative, so that we call that absolute value of a, you're going to have a shrink if absolute value of a is between 0 and 1. And we're going to have a stretch if the absolute value of a is greater than 1. Translations. X minus h. If you replace the x with x minus h, it's going to do the opposite of what you think and move it right h units. X plus h is going to move it left h units. If you add a number at the end, a plus k, that's going to move it up k units. And if it's a minus k, it's going to move down k units. So in a nutshell, this is what we've been doing. All right, so let's do a couple of graphs together. In example 1, g of x equals negative 0.5 times 5 to the x. All right, what is the parent function? What would be the parent function? Yeah, Sydney? Good job. So y equals 5 to the x. It says fill in the table with 5 key points for the parent function. So we do negative 2 to 2. So go ahead and plug in those x values into the parent function. I personally prefer to start with the bottom because I know how to do 5 squared. And then I work my way up the table. So 5 squared would be 25. 5 to the first is 5. What's 5 to the 0 power? 1. All right, now you really should not be touching your calculators. 5 to the negative 1 is 1/5. 5 to the negative 2 is 1 over 5 squared, or 1 over 25. It says now, state all transformations. I see two things. I see two things with g of x equals negative 0.5 times 5 to the x. What are those transformations? Yeah, Davey? Awesome. The negative causes the reflection over the x-axis. What does the 0.5 do? Yeah, Becca? Good job. It's a vertical shrink of 0.5. It says use mapping notation to explain how each key point changed in the transformation. Nothing happened to x, but the y value is being multiplied by negative 0.5. So I'm going to pause a moment, and what I want you to do now is I want you to fill in the new table for the transformed graph. X's all stay the same. Now use your calculators if you need to, and multiply all the y values by negative 0.5. Because we wrote down that there's a reflection over the x-axis, this one should be upside down. Okay, this one should be reflected. over the x-axis. Now, do you realize that negative 0.5 is really equivalent to negative 1/2? Negative 0.5 is equivalent to negative 1/2. So you could, I personally did this without a calculator, and I multiplied by negative 1/2, but you can do a calculator. So I got negative 12.5, negative 2.5, negative 0.5, negative 0.1, and negative 0.02. The domain is negative infinity to infinity. I can see the y-intercept in my table. The y-intercept, x is 0. What would be the horizontal asymptote? What's the horizontal asymptote here? Nice job, y equals 0. We talked yesterday. What is the only way that you're going to move the horizontal asymptote? Yeah, Ella? Awesome. If my graph is shifted up or down, that's where the horizontal asymptote goes. Otherwise, it's y equals 0, the x-axis. Yes? Okay, great question. Do you see what we wrote down up here? How do you know if it's been shifted up and down? Did it have a plus k number? It did not, so that's how we know. All right, so let's go ahead, and you are required to sketch the the horizontal asymptote. So make sure you're drawing a pretty dashed horizontal asymptote. I think we can get away with going by ones. At 2, it's negative 12.5, so just make that one go down a little. Then let's go ahead and plot the original. 225 is like, whoo, way off my grid. So can you see, like that's a nice reflection from the parent graph. Now I need to circle back to my range. Don't forget it. I know that I do it last. The range represents the y values, my y values. So do you see this is going negative infinity and getting as close to 0 without touching? So I'm going to write my range. The y values are negative infinity to 0. All right, questions? Yeah. This one did say graph the parent and the transformed. All right, I want you to try example 2. I'm going to pause and give you 3 or 4 minutes head start on me, and I want to see how far you can get before I start it. I'm going to walk around the room and ask questions. State your parent function equation. Fill in the table with 5 key points to the parent function. Do your mapping notation. Get as far as you can. Y values don't change, so you're going to recopy the Y value. But this would be negative 2 minus 2, which is negative 4. So you're going to subtract 2 from every single one of those. All right, I'm going to go ahead and start this one. My parent function is y equals 4 to the x. Then I'm going to plug in negative 2 to 2. This is going to be left 2. So then that's x minus 2 comma y. So that's negative 4, negative 3, negative 2, negative 1, 0. But then my y values stay the same. The domain is negative infinity to infinity. My y-intercept is 0, 16. What's the horizontal asymptote? Y equals 0. What's the only way, what transformation shifts the horizontal asymptote? Up, down, okay? Up, downs. All right, so 16 is going to go off my grid. But don't forget to sketch that horizontal asymptote. That's really your boundary. So 0, 16, I'm just going to eyeball, that's up off of there. Negative 1, 4, negative 2, 1, And then you are eyeballing teeny tiny ones there. The parent graph was 0, 1, 1, 4, 2, 16. Do you see? Oh, that's really cool. When you look at that one, can you see that it's literally right 2 units? Those are all just moved right 2 units. My range is 0 to infinity. All right, show me thumbs up, out, or down. How do we feel about the graphing now? Up, out, or down? All right, nice. Example 3. I'm going to pause a moment, and I want you to describe the transformations. Yeah. So, do you see the range did change in number 1?
Yeah.
Okay, so in number 1, do you see this was a reflection? So if there's a reflection, that's going to change it, and an up-down is going to change it. So here, it now went from 0 down to negative infinity. So I wrote, we went with the smaller value first, negative infinity to 0. If I take my graph and I shift it up, let's say 4 units, and it's up, it's a growth one, then that's going to be 4 to infinity. So up downs affect it, and reflections over the x-axis affect it. Okay, great question. Otherwise, it's 0 to infinity. Again, if you haven't started yet, example 3, do A and B. State all the transformations that you see. All right, at your tables, have somebody read off what you got for A and B. All right, let's check them here. Heard some good things. Letter A and number 3. Vertical stretch of 3, right 1, up 8. Letter B, reflection over the x-axis. Vertical shrink of 1/2, left 5, down 9. All right, example 4. Write a function for the indicated transformation. The parent function is y equals 2 to the x. I'm going to pause and give you a moment if you haven't already. Go ahead and try for A and B. The parent function is y equals 2 to the x. Yeah, go ahead and at your table have somebody read off your answers for A and B, compare. All right, let's check it here. Part A, I had y equals 3 times 2 into x plus 4 power. Part B, y equals negative 1/5 times 2 to the x, and then you have a plus 4. All right, questions on that one? Yes, you can do f of x, you can do g of x. Yes. All right, example 5 is one more sketch. I'm going to give you about 3 or 4 minutes head start on me. Let's see now. I think we can, team. Let's go the whole way through. See if you can sketch with all the information asked for in example 5. State your parent function. Get a table of values for the parent function. State the transformations. Mapping notation. Make a new table. And sketch both the parent function and the transform. One comment I want to make that I noticed on homework, if you have a fraction to an exponent, if you have a fraction to that x power, you must put a parenthesis around the 1/5. Let me say that again. I need everybody listening. If you have a fraction to an exponent, the fraction has to be in a parenthesis. If you don't, the way that you're writing it is only the numerator to that x power. And that's not what you mean. So be careful with that. Yeah, let me do a little bit here to make sure, like, you don't go too far doing the wrong thing. Now, are you okay? 1/5 when you square it is 1/25. 1/5, 1. Now be careful. 1/5 to the negative 1 flips it to 5. My transformations are a vertical stretch of 3 and down 2. So that's going to be x comma 3y minus 2. So nothing happened to my x, but when I did the y's, whoa, this one's going to go like crazy. This is going to go 73, 13, 1. I had negative 1 and 2/5, negative 1 and 22 25ths. It's okay to do decimals. All right, so on this one, I cannot go by ones because 2 of those are going to be off my grid. So what I'm going to do, now my x-axis, I am going to go by ones. But I went ahead and went by 10. So what I said to you before, I'm going to repeat myself from yesterday. If your table has only one value that's going off the grid when you go by ones, that's okay. But if you have 2 or more points that go off the grid, you have to change your scale. I have 2 values that went off the grid, so I had to change my scale on my y-axis. This one has gone down 2 units. So notice my horizontal asymptote is at y equals 2. I do have a y-intercept of 0, 1. All right, Jillian, I'm going to try it. Look at this. Look at me. Okay. So I'm going to make my dashed line. So do you see that's not to the first tick? Whoa, I'm doing a bad job. Oh, there. Okay, cool. Wait, did it really bad? That's so pretty. Thank you. All right, then negative 273. I have negative 113, 0, 1. And then those are going below the x-axis. Whoops. But just a teeny tiny bit. And then this one stays above the x-axis like that. Yeah. Oh, yeah. Sorry. It's down 2. Thank you. Thanks for that catch. Yeah, it's y equals negative 2. So now my range is negative 2 to infinity. Okay, that one was a tough one.